Pepsi, one of the most popular soft drinks in the world. Every day, millions of people crack open a bottle, take a refreshing sip of ice-cold Pepsi, and enjoy that familiar flavor. What keeps so many fans hooked on Pepsi is its signature taste, a pleasant sweetness blended with a hint of bright citrus, delivering an instant rush of refreshment from the very first sip. So how is Pepsi actually made? To find the answer, we visited the largest Pepsi factory in Europe and uncovered the entire journey behind this iconic beverage. The original formula for Pepsi Cola was created in 1893 by pharmacist Caleb Bradham in New Bern, North Carolina. At Bradham's pharmacy, he developed a digestive aid beverage that did not contain the addictive substances commonly used at the time. In the beginning, the drink was called Brad's Drink, made from ingredients like sugar water, caramel, lemon oil, cola nuts, nutmeg, and a few other additives. In 1898, Bradham renamed it Pepsi Cola and began distributing it more widely. From an experimental formula in a small pharmacy, Pepsi gradually grew into a global brand, contributing to PepsiCo's annual revenue of over $90 billion during 2023 to 2024. This facility isn't just an ordinary beverage factory. It's the largest PEPSICO plant in Europe and one of the biggest mega factories of soft drinks in the world. So, where does the Pepsi bottle in your hand actually come from? Everything starts with something that seems the simplest: water. Here, water is pumped from one of the factory's 4 underground wells, located about 250 meters below the surface. It then passes through a multi-stage filtration system that removes impurities, eliminates any odd odors, and stabilizes the quality. Even a slight deviation in the water standard could force an entire batch of soda to be discarded. Next comes CO2. This gas doesn't just create the iconic hiss and sparkling fizz when you open a bottle. It also helps preserve the beverage by creating an environment that's less favorable for microorganisms to grow. But what truly sets Pepsi apart, the thing that makes it unmistakable among all soft drinks, is its concentrated flavor essence. This formula has been kept secret for more than 100 years and is produced in only 3 factories worldwide. Each day, the factory prepares nearly 20 different syrups for its various beverage lines. The concentrated essence is pumped into large tanks and mixed with water and sugar in extremely precise ratios, forming the foundational syrup that gives Pepsi its signature flavor you're familiar with. Once everything is ready, the mixtures are transferred into large blending tanks. All ratios are pre-programmed in the system, ensuring that no matter where you drink it, a can of Pepsi will taste almost exactly the same. That signature Pepsi flavor we all recognize comes from a combo of notes: sweetness from sugar and sweeteners, a hint of lemon brightness, a gentle warmth from vanilla, and a small amount of caffeine, a mild stimulant that helps you feel more alert. The caffeine is diluted in water before being pumped into the blending tank as the final layer of the flavor profile. It may sound as simple as mixing a jug of water, but the real magic only starts when the drink is infused with CO2 to carbonate the beverage. The sweetened mixture is chilled to just above freezing and then pushed through a high-pressure CO2 injection system. The colder the liquid, the easier it is for CO2 to dissolve. That's why, when you crack open a can of PEPSI, the sudden drop in pressure releases the CO2, creating those countless tiny bubbles and that incredibly satisfying hiss. The mixture is also infused with a small amount of preservatives to inhibit bacterial growth, along with antioxidants that prevent the color and flavor from degrading over time. Every step strictly adheres to food safety standards. From each production batch, samples are taken straight to the in-house lab. Here, technicians examine every parameter, the amount of dissolved CO2 to guarantee the perfect level of fizz, the ratio of sugar and sweeteners to preserve the signature sweetness, as well as color, acidity, and temperature. They even conduct small tasting sessions to make sure everything matches the familiar PEPSI flavor. Only when all measurements fall within the approved range is the batch given the green light to move forward. The process we followed today starts with reusable glass bottles of about 7 ounces, small, compact bottles that fit neatly in the palm of your hand. After being collected from supermarkets, restaurants, or food stalls, these empty bottles return to the factory and are sent straight onto the conveyor belt. From there, they move into a multi-stage washing and sterilization system. Once perfectly clean, each bottle passes through an inspection area. If any crack, chip, or foreign object is detected, that bottle is immediately removed from the line. Only bottles that meet the standard are sent to the filling station, where Pepsi is filled to a precisely measured volume. Next, the capping machine presses an aluminum crown cap tightly onto the bottle mouth. The bottles then pass through a dryer to return to room temperature, preventing condensation when they're packed. Finally, they're neatly arranged into crates and ready to head back to the market. This reusable glass bottle system not only adds a fun retro vibe, but also reduces packaging waste and single-use plastics, making the entire PEPSI production line greener right from the start. If glass bottles give off a retro vibe, then most of the Pepsi bottles you see in supermarkets today are actually born from tiny plastic pellets that look like test tubes, known as PET preforms. These preforms are heated in an oven to the right temperature and then placed into molds. Under extremely high air pressure, each preform is blown and stretched within fractions of a second into its final bottle shape, a slim body, thick base, and narrow neck for easy gripping and pouring. The whole process happens so fast you can barely blink. The bottles are cooled and sent through an internal rinsing system to remove any dust or particles left from the heating process. When the bottles are ready, the Pepsi mixture, syrup and water chilled to the ideal temperature is filled in. This temperature is tightly controlled to minimize excessive foaming, keep the CO2 stable, and ensure the flavor remains unchanged. Next comes the finishing touches. An automated capping machine drops each cap into place and twists it tight to seal in the carbonation. Immediately after, the bottles pass through a high-speed labeling machine that can handle around 200 bottles per minute. At the end of the line, robots stack the bottles into packs and trays according to each order, from small 6.7-ounce bottles to large, nearly 67-ounce, family-size ones. Altogether, the factory can produce dozens of different products and bottle sizes, all beginning from the same tiny component, the PET preform. For Pepsi cans, the journey begins with empty aluminum shells so light you can barely feel them in your hand. Each layer of cans is separated, fed onto the conveyor belt, and organized into a single file line for easier control. From there, the cans are flipped upside down at a 180-degree angle and sent through an internal rinsing station, where food-grade water is sprayed forcefully to remove any dust picked up during transport. Only when they're clean inside and out are the cans allowed to move on to the filling machine. This system uses 72 filling valves operating simultaneously, pumping pre-chilled Pepsi into each can with high precision. Right beside it, the seaming machine, with multiple sealing heads, places an aluminum lid onto each can and rolls the edges tightly to lock in the carbonation. The entire fill and seal block can process up to about 1,000 cans per minute, moving so fast it looks like a continuous stream of metal. Next, An automatic inspection system measures the liquid level inside each can. If any can falls short of the required 12 ounces, a piston lightly nudges it off the line. The cans that meet the standard are then rotated upright, sent through an air dryer to remove any remaining moisture, and finally guided into the packaging area. Here, the packing machine groups the cans, places them into boxes, seals both ends with adhesive, and prints tracking codes on the cartons. The boxes are then carried up a spiral conveyor to the palletizing area, where they're tightly wrapped in stretch film for safe transportation. Every year, this line produces around 1.9 million cases of Pepsi cans, and during peak summer months, as many as 150 trucks leave the factory in a single day, delivering ice-cold Pepsi to consumers across the United States and many other parts of the world. And that's how it all comes together. From the water wells, syrup tanks, and lab tests to the bottling and canning lines, the full journey of a Pepsi can before it ever reaches your hands. But the world of carbonated soft drinks doesn't stop there. On another production line, backed by a long history and one of the most closely guarded formulas in the industry, an iconic rival is also being produced every day on a massive scale. But before diving into each stage of the production process, let's take a look at the bigger picture. Each year, the global ready-to-drink non-alcoholic beverage industry generates around $700 billion in revenue. And within that massive world, Coca-Cola is the dominant name. Today, Coca-Cola holds roughly 40 to 45% of the global carbonated soft drink market. With distribution of more than 200 different beverage brands and operations spanning over 200 countries worldwide, Coca-Cola is more than just a drink. It is a global beverage ecosystem, woven into the daily lives of billions of people. Coca-Cola's journey began in 1886, when pharmacist John Pemberton in Atlanta created a syrup derived from a product he had developed earlier, French wine of coca. At its core, this was a wine mixed with caffeine and extracts from coca leaves, widely marketed as a remedy to relieve headaches, fight fatigue, and boost alertness. Just 2 years later, in 1888, John Pemberton sold the secret formula and brewing rights to businessman Asa Candler for only $2,300. In 1892, Asa Candler founded the Coca-Cola Company, investing heavily in advertising and adopting a bold strategy, offering free samples to customers at soda fountains. Through this approach, Coca-Cola quickly outgrew its original scale, and by the early 20th century, had become one of the most recognizable soft drink brands in the United States. During this expansion, Coca-Cola continued to refine its formula. By 1904, the company had completely removed cocaine, and from then on, used only decocainized coca leaves in production. And in 1915, an icon was born, the Coca-Cola Contour bottle, designed to be instantly recognizable even in the dark or when broken, laying the foundation for a brand identity that has endured for more than a century. At the heart of the entire system is the beverage concentrate, the foundation that creates the familiar Coca-Cola flavor. In reality, only a very small number of people, rumored to be as few as 2, know the complete formula. This formula is stored in a high-security vault, located at the World of Coca-Cola Museum in Atlanta. The public can see the vault with their own eyes, but no one can access what's inside. Globally, there are only about 19 specialized facilities, certified by Coca-Cola, to produce the concentrate. At these sites, ingredients are measured and blended with near-perfect precision, then sealed into large containers or tanks and shipped to bottling plants around the world. Inside the factory, water, makes up about 90% of Coca-Cola's formula. For that reason, water quality is not just important, it directly determines the final taste. At many plants around the world, Coca-Cola draws water from wells located on-site, tapping aquifers roughly 800 feet underground. This water is then rigorously disinfected and passed through multiple layers of advanced treatment technology, including nanofiltration, to achieve near absolute purity. This meticulous water treatment process ensures that every bottle of Coca-Cola, no matter where it is produced, delivers the fresh, consistent taste consumers expect. With the secret formula in hand, we can now step inside the factory and see how each bottle of Coca-Cola is made. Everything inside a Coca-Cola plant begins with the secret syrup, the true soul of the drink. It arrives at the factory quietly, transported by forklifts in plastic containers and large drums, then sent directly to the mixing area. There, the syrup is fed into a blending system along with water. The dilution ratio is tightly controlled, typically around 1 part syrup to 5 parts water, creating the familiar base of Coca-Cola. Next, depending on the specific product line, sweeteners are added in precisely measured amounts, then pumped through a complex network of pipes into holding tanks in the adjacent area. The next critical step is carbonation, where the mixture meets CO2 gas. Under high pressure, carbon dioxide is forced to dissolve into the liquid. This process creates the signature fizz you experience when opening a bottle or can of Coca-Cola. CO2 is unique in that it dissolves in water far more readily than oxygen or nitrogen. Thanks to high pressure, Coca-Cola can absorb several times its own volume of CO2, producing a strong yet smooth carbonation. Once carbonation is complete, Coca-Cola truly becomes the familiar carbonated beverage we know. Before a bottle of Coca-Cola is filled, everything begins with absolute cleanliness. Even newly manufactured bottles are thoroughly washed using an automated system. On this production line, speeds can reach 20,000 to 60,000 bottles per hour. Next, the empty bottles move into the filling stage, the central component of the production line. Coca-Cola is filled into the bottles under precisely controlled pressure to ensure a smooth, consistent flow. The system operates at around 5 degrees Celsius to minimize foaming, keep CO2 dissolved, and ensure uniform fill levels. Each filling machine can process up to 550 bottles per minute. Immediately afterward, an automated capping machine seals each bottle, locking in the CO2. The bottles then move on to the labeling stage. Each bottle receives the iconic red and white Coca-Cola label, which not only serves brand identification but also contains critical information. The label includes the production batch code, manufacturing date, and expiration date, enabling precise traceability and quality control. For Coca-Cola cans, the process is just as rigorous. First, the cans are cleaned using a specialized sanitation system to ensure they are in perfect condition before filling. The Coca-Cola syrup is then pumped into a closed filling line. Immediately after filling, the cans are sealed. This step requires extremely high precision, as each can lid must withstand significant internal pressure to keep the CO2 stable inside. Finally, high-tech inspection systems scan every bottle to detect defects, such as cracks, loose caps, or improper fill levels. Any bottle that fails to meet standards is automatically removed from the production line. After passing quality control, approved bottles of Coca-Cola are transferred to the packaging area. There, the bottles are grouped into packs or cases and then wrapped in shrink film. The shrink wrap is heated to tightly seal each case, creating a protective layer that stabilizes the product and shields it from external impact during transportation. The cases are then consolidated into larger batches and fed into an automated palletizing system. Palletizing robots operate 24/7, ensuring precise and uniform stacking while optimizing load capacity for transport vehicles and reducing the risk of workplace injuries. Once complete, the pallets are sealed and moved into storage to await distribution.
Nothing wakes up your taste buds better than an ice-cold, fresh, and energizing glass of orange juice. Every day, Americans consume about 20 million gallons of orange juice, an impressive figure that proves the enduring appeal of this seemingly simple drink. Yet behind that clean, delicate sweetness lies a global industry worth billions of dollars. Billions of oranges are planted, harvested, and pressed with minute-by-minute precision before crossing the ocean, from Florida's sun-drenched groves to the sprawling farms of Brazil. Join us on that journey. A perfect glass of orange juice always starts with a perfect climate, and in the United States, that means Florida, the nation's orange capital. Thanks to warm year-round sunshine and gentle seasonal rains, the state supplies up to 75% of the country's orange output, creating ideal conditions for some of the juiciest, most flavorful oranges in the world. Yet behind that abundance lies a tough paradox. America's orange and orange juice industry is shrinking. Consumer demand remains high, but production has fallen sharply. In the 2024 to 2025 season, total U.S. orange output is projected at just 2.46 million tons, down nearly 8% from the previous year. This decline has forced juice processors to lean on imports, and Brazil has become the global linchpin, supplying nearly 90% of the orange juice imported into the U.S. and cementing its status as the world's largest orange juice exporter. Behind those figures is a finely tuned operation, from seedlings and harvesting technology to rigorous quality control systems, where every drop of orange juice must meet exacting standards before entering production. And it all begins with a tiny but precise measurement. Growers don't just eyeball the peel or judge by feel. They use a specialized device called a refractometer. A single drop of juice on the glass is enough to read the brick's level, which indicates the fruit's natural sugar content. When that reading hits a minimum of 10%, about 10 degrees Brix, the orange is considered ready for juicing, ensuring the gentle sweetness and balanced flavor in the cool, fresh sips you enjoy each morning. Across vast groves, massive machines roar to life. They're known as limb shakers, a clever invention that can harvest oranges in a flash. As the shakers clamp two arms firmly around the trunk, they vibrate at a powerful, precise frequency, shaking thousands of oranges onto the conveyor below, which carries them straight into a collection truck moving alongside. In just 1 minute, a single machine can harvest up to 2 tons of oranges, more than 2 million pieces of fruit per day, enough to keep entire processing lines running continuously. Still, not every orange comes off a tree by machine. On many smaller farms, the work is done by hand. Pickers carefully pluck each ripe fruit, load it into large burlap bags, then empty those into bins. From there, tractors haul the oranges to special trailers called gondolas, positioned in convenient spots for loading. Once full, Tractor trailers transport the fruit to the processing plant. Convoys of trucks roll into the unloading area, where trailers heavy with oranges are lifted onto massive hydraulic tilting platforms. Within seconds, the platform eases to about a 30-degree angle, and tons of fruit pour into the receiving system below, gliding smoothly under their own weight. This mechanism makes unloading fast, safe, and almost entirely bruise-free. From there, the oranges begin a new journey, moving along long conveyors toward the wash area. Here, they're sprayed with a mix of water and a mild alkaline solution, then pass under a series of continuously rotating brushes that scrub every peel. High-pressure spray nozzles work non-stop to rinse away dust and debris, while the brushes meticulously clean each fruit as if polishing Florida sunshine back onto their skins. This step doesn't just clean the oranges thoroughly, it also removes the natural wax, a coating that helps fruit stay fresh longer, but, if left on, would diminish juice quality. Once gleaming and clean, the oranges move on to preliminary sorting. Along the conveyor, the watchful eyes of workers scan continuously. Any fruit that's bruised, damaged, or shows signs of decay is pulled out immediately. Next, the oranges enter the automated grading system. Along the conveyor, hundreds of rollers spin continuously, allowing cameras and sensors to inspect every surface of each fruit from all angles. This enables sorting by size and diameter, so every orange matches perfectly with its corresponding juicing head. The system uses FPGA-driven, sensor-equipped cameras that can identify an orange's diameter and color with up to 94% and 90% accuracy, respectively. In parallel, AVIS/NIR spectrometer measures Brix degrees BX, the fruit's natural sweetness, even as the oranges move along the line. As a result, each orange is selected not only by size, but also by ripeness and flavor profile, ensuring consistent quality in every drop of juice. After precise grading, the finest oranges are sent straight into the industrial juicing system. Each fruit is seated in its own pressing cup, secured by a spiked metal ring to hold it firmly during compression. When sensors confirm proper positioning, a steel piston descends from above, forcing fresh juice to flow quickly. In just a few seconds, the juice, pulp, and peel are completely separated, cleanly, efficiently. From there, the fresh orange juice travels through sealed pipes to large holding tanks, where filtration removes any remaining pulp. That pulp is then blended back into special batches for people who prefer extra pulpy, more textured juice, much like what you'd squeeze at home. At industrial scale, a line like this can process up to 1,000 oranges per minute, the equivalent of more than 500,000 gallons of juice per day, enough to keep the global market well supplied year-round. The remaining peel isn't wasted. Immediately after pressing, it's routed to an essential oil extraction line, where the natural aromatic oil is separated. The very orange note used in perfumes, body washes, scented candles, and skincare products. According to USDA data from 2024, Brazil's exports of orange essential oil rose by nearly 7% from the previous year, reflecting strong demand from the global flavors and fragrances sector. As a result, every orange is used to the fullest, from juice and pulp to peel. After pressing, the orange juice follows one of two different paths, depending on the production goal. For concentrated orange juice, the fresh juice is routed through multi-effect evaporators, where about 80% of the water is removed using heat and vacuum. The result is a thick concentrate that retains most of the fruit's natural sugars, acids, and aromas. This concentrate is then deep chilled and frozen solid into blocks of frozen concentrated orange juice you often see in the supermarket freezer case. It's a common method at large-scale plants in Brazil and Florida, cutting shipping volume by up to 5 times compared with fresh juice. For single-strength juice, the process is designed to preserve the most natural flavor. The juice passes through flash pasteurization, heated to about 85 degrees Celsius to eliminate microbes, then rapidly cooled to 1 to 2 degrees Celsius to protect vitamins and taste. This juice contains no added sugar or additives, so it may carry the 100% orange juice label under the 2024 USDA standard. After pasteurization, The juice is stored in massive chilled tanks, each holding over 1 million gallons under airtight conditions for 18 to 24 months with no significant loss of flavor. Before bottling, random samples are sent to the lab to check acidity, sweetness, bricks, color, aroma, and microbiological stability. This ensures every bottle on the shelf meets consistent standards for quality and food safety. Now the juice reaches its final leg, the bottling stage. On gleaming stainless steel lines, hundreds of empty bottles glide along the conveyor into the automatic filling zone. Integrated sensors and electronic scales at the bottleneck measure every drop as it's dispensed, ensuring each bottle hits exactly 59 ounces, the equivalent of juice from about 16 fresh oranges. In the blink of an eye, the automatic capping machine twists each cap tight, so fast it's almost impossible to see with the naked eye. Right after that, the bottles move to the labeling station where they receive brand labels, product details, and nutrition facts. Finally, the finished bottles are packed into multi-packs, neatly shrink-wrapped and stacked squarely onto pallets. An industrial robotic arm wraps a clear protective film around each pallet, keeping every bottle secure and ready for long hauls. The pallets are then loaded onto refrigerated trucks. The cargo bay temperature is kept steady to preserve freshness and original flavor until these bottles appear on store shelves across the country. And if you enjoy behind-the-scenes journeys like this, hit like, share, and subscribe to discover more fascinating stories behind the everyday products we all know.